Is understood, no? This one, reduction. Right, you got this one, no?
Yes, sir, I got it.
Okay, so what we are taking? We are taking first function is okay. So the first function is what? X power n, right? dv is
Yeah.
cos x dx. So v is sin x. Okay,
Yes, sir.
u v minus v du. Okay, right now.
Yes, sir.
Okay, next 64. Shreyas, you also got number this one.
Yes, sir.
Okay. Okay, this method did I tell you? I mean, easy way of doing this integration. For example, ln x whole power n, and this is 1. Okay, okay. This one, what is the first function you are taking?
Sir, ln x whole power n. And then
Okay,
one is the second function.
what is the second function? This becomes n into ln x whole power n minus 1 whole by x, right?
Yeah.
Okay, so this is the first function. This is the second function. Okay, what we are doing? Here we are differentiating. Here we are integrating, right? So our integral
Yes, sir.
is directly this into this minus this into this. Okay, this is this because this is our v and this is our uv minus v du. Okay, we'll just write the
Yeah.
two functions. First one differentiate, second one integrate, and this into this minus this into this. Okay, that this into this is the integrate, right? uv,
Yeah.
which is x into ln x whole power n. Okay, minus integral of this into this, which is n into ln x whole power n minus 1 dx. Okay, this n also we can bring it out. Okay, that is what we are getting. Cool. So this is very easy. Okay, now try this 66.
Sir, I'm not reaching the answer.
Sir, even I'm not completing it. I can't complete it also.
Okay, okay. So what did you take? First function is root 1 minus x square. Second function is 1. 1 by 2 under root 1 minus x square and minus 2x, right? And this is x,
Yes.
right?
Yes.
This one only, no?
Yeah.
Okay, so this into this will become root of. Okay, so what is our integral now? What is our integral? Our I equals root of 1 minus x square, this times into x, minus integral of this, it's actually plus, right? Minus integral of minus
Yes.
2x by 2x, which is like minus x by under root 1 minus x square into x, right? Dx, right?
Yeah.
Okay, this is nothing but integral of 1 minus x square into x, right? Plus integral of x square by root 1 minus x square, right? Dx,
Yeah.
right? Right now?
Yes, sir.
Okay, or let's keep this minus like this only. Minus, minus, okay? Okay, this one, now what we want, this also is, it's not an easy integration, right? This is
Yeah.
not an easy integration. What we will do, we'll cleverly manipulate this. This part, okay, this part becomes, we can write it like 1 minus x square plus x square, right? 1 minus x square plus 1. Sorry, 1 minus x square minus 1, right? You can write it like this,
Yeah.
no? Okay, by
Yes.
under root 1 minus x square, right? Dx. This becomes minus of integral of 1 minus x square by root of 1 minus x square dx minus integral of 1 by under root 1 minus x square, right? Agree?
Yes,
Okay,
sir.
this becomes, this we can write it as minus of, this is actually root on 1 minus x square by root 1 minus x square. This is actually equal to root of 1 minus x square. This is actually our original I, right? We wanted to evaluate this one only,
Yes.
right? This is actually our
Yeah.
original I. Okay? I minus, what is this? This integral we know, sine inverse x, right? Agreed.
Hmm.
Sine inverse x, if we
Yes,
differentiate
sir.
under root 1 by under root 1 minus x square, right? So, I
Sir, can we
equals,
take this as 1 by?
come again.
Sir, can we take that as 1 by I? Because it's 1 by root.
No, it is not 1 by I, no. See, I is this one, integral of under root 1 minus x square. Next, I is not this one, right? I is the whole integral. Understood?
Oh,
Okay, I is not this one. I is not 1 to under root 1 minus x square. I is the whole of this integral, right? So this one only we can take it as I. This integral anyway we know, right? 1 by under root 1 minus x square sine inverse x. We know, right? Okay? I equals x under root 1 minus x square minus I plus, right? I equals x under root 1 minus x square minus I plus sine inverse x, right? So 2I becomes this. So I becomes x under root 1 minus x square plus sine inverse x whole of this by 2. Understood? Plus some constant. Got it now? That is this one.
Yes,
yes,
sir.
sir.
Okay, so he did not do, he stopped here. Okay, understood now? He stopped at sine inverse x, but he is, uh, so he has done till this part only. Understood now?
Yes, sir.
So he did not evaluate this integral. He has actually left it as is. Okay, integral of 1 minus 1 by under root 1 minus x. So he left it as is. Okay, just do this once again. You're able to integrate this one?
Yes, sir. Now I'm getting it.
Okay. Okay. So, um, okay. I'm projecting your JEE syllabus once again. Okay. So consider if it is A is 1, you know how to integrate this one, right?
Yes.
Right?
Yeah.
Okay. You know how to integrate this one, right? A is 1. This is sine inverse x, right? This is tan inverse x, right?
Hmm.
Agree? You know how to integrate this one, right?
Yes, sir.
Okay. Now you learnt how to integrate this one, right? Not plus or minus. You learnt which one? You learnt one of this. Which one is this? You learnt 1 minus x square. That is one of this. A square minus x square, right?
Yes, sir.
Okay. You learnt one of this also. Do you remember? In hyperbolic functions.
Hmm. Yeah.
Okay. Uh, okay. So you learnt one of this. Do you know how to do this?
Uh, yes, sir. But then I forgot.
Okay. We discussed. Okay. We write this as difference of two terms. Okay. Cool. So just keep note. This is only these types of integrals are there in our syllabus. Okay. Okay.
Okay,
Integrals
sir.
using trigonometric identities, simple integrals of this type. Okay. These and all questions that you get would be of would be can be reduced to these forms. Okay. Then algebraic, exponential, logarithmic functions by substitution. You know substitution method, right? You know by parts, right? And partial fractions, you don't know it, right? Integration using trigonometric identities, you know, and simple integrals of this type. Okay. Okay. Let me just project a
Yes, sir.
different screen now. Okay. Let me just project a different screen. You can see my screen now.
Yes, sir.
Okay. You know these functions, right?
Yes, sir.
Hyperbolic functions. Sin hx, cos hx. You know by now you know how to draw these, right?
Yes, sir.
Yes, sir.
Tan hx and sine inverse and cos inverse, right? You know how to draw these functions, right?
Hmm.
Okay, you know these identities also, right? You know these identities also, and we were able to do these identities also, right? And we're just doing a small recap of all hyperbolic functions. Okay, we are able
Yes,
to
sir.
prove these also, right? You remember this, no?
Yes,
Yeah.
sir.
Okay, so we are able to prove this, and then okay, we are able to prove all of this. And you remember the inverse functions also, right? This is the original function. Yellow is the original function. This is the inverse. Inverse means reflection with respect to this pink line, y equals to x, right? Mirror image with respect to this line. Okay, blue is the inverse of yellow. Yellow is the inverse of blue, right? No, here also, yellow is the inverse of blue. Blue is the inverse of yellow. And cos h, we left the other part. Why we left the other part? Because to have an inverse, uh, we cannot have the second part of the graph, right? The function has to be 1, 1, right, Noma? That's why we left
Hmm.
this part, right? We left this part, right?
Yes, sir.
You remember that, no? Cos h, we left this part. Why we left this part? Because if we keep that part, we cannot have an inverse, right? We cannot have an inverse function. Okay, so you know these graphs also, right? You know cos x graph, secant h inverse, all the inverse functions. Okay, now did we do this? Inverse functions, inverse function expressing in terms of logarithms. Do you remember doing this, ma?
No, sir.
Okay, okay. So for example, sin h y. Okay. So x equals to sin h y. Okay, okay. What we want is sin h inverse x. Okay, what is sin h x? E power x minus e power minus x by 2, right?
Minus e power minus x by 2.
Ah, right. So sin h inverse x, we are calling it as some y. Okay. Let's assume sin h inverse x equals to y. That means what? Sin h y equals x, right? But what is since y? It is e power y minus e power minus y by 2. We can write it like this, right? E power y minus 1 by e power y, which means e power 2y minus 1 by 2 into e power y, right?
Hmm.
Okay, if we do the cross multiplication, e power 2y minus 1 equals to x into 2 e power y, which is this equation, right? But this is a quadratic equation where e power y whole square minus e power y into something minus 1, right? What are the roots? Minus b, which is 2x plus or minus b square. What is 4x square minus 4 into 1 into this minus 1, right? These are the roots, right? E power y should be x plus or minus under root x square plus 1. Agree, Amma?
Yes, sir.
Okay. So what does that mean? Y should be, if you take logarithm on both sides, y should be log of x plus under root x plus square plus 1 or x minus under root x square plus 1. But we cannot take x minus under root x square plus 1 because that will be a negative number, right? That's why you're taking only positive. Logarithm has to be always positive, no? Log, it can take only inputs of positive numbers, right, Nama?
Yeah.
So y, that's how we got y. But what is our y? Sin h inverse. Okay. So basically, sin h y we are able to express in terms of e power y's and all, right? Similarly, inverse function of this also we should be able to express in terms of logarithms or e power whatever, whatever. So in this case, we are able to express in terms of logarithm. Okay. So
Okay.
similarly, you can do for other things also, right? Cot h inverse, cos h inverse, etc., etc. Okay, and you remember these things, right? We know that we did the derivatives of all of this, right? Remember
Yes,
this,
sir.
Rama? We did the derivatives and we did the uh, antiderivatives, obviously, which means the integrals, right? You remember all of this, right?
Yes, sir.
Okay,
Sir, can you recap the inverse ones of hyperbolic ones?
inverse ones.
A
So
little tough. Yes,
first you
sir.
did this, no?
Yes, sir. That is fine.
This part you remember, no? So for example, you
Yeah.
want to do inverse of this one, okay? Cos h inverse. Okay, what we do? Cos h inverse x equals to y. Okay, that means
Y is equal to.
cos hy equals to x. Okay, now we differentiate this on both sides. What is derivative of
Yes,
cos
sir.
hy?
It's e raised to y plus e raised
No,
to
no,
minus
not,
y by
not that
2.
much. Derivative of cos hy is sin hy, right? Sin,
Yeah.
if you do differentiate on both sides, sin hy dy by dx equals to 1, right? Dy by dx
Yes, sir.
equals to 1 by sin hy. Okay. Now we also know cos h square y minus sin h square y equals to 1, right?
Yeah.
Agree, no?
Yes, sir.
The very one of the first identities. You remember that? Where is this? This one. Where is this? Cos h square minus sin h square equals to 1, right? This identity.
Yes, sir.
Okay. From this, what we get? Uh, where is this? From this, what we get? Sin hy equals cos h square y minus 1 square root of this, right? Okay. But cos hy is actually our x. This means under root of x square minus 1. So this integral equals, sorry, this differential equals under root of x square minus 1. Understood? That is how we got
Yes, sir.
this. Derivative of cos h inverse x equals to 1 by under root x square minus 1. Okay?
So for derivative of sine inverse x, it's 1 by root of 1 plus x square. Yeah. So,
Yes, yes, same thing, same thing. Instead of cos h, you will take sin h. Sin h inverse x equals to y. Sin hy equals to x. Cos h dy by dx equals to 1. Okay? So 1 by cos hy. Cos hy you will express again in this terms. Okay, ma? Okay, you try
okay,
this
sir.
first. You try this. Otherwise, you try this once. Sin h inverse y. Try to differentiate this using this method.
Yes, sir.
And you remember the derivatives of all 6 trigonometric functions, no? Regular trigonometric and inverse trigonometric.
Yes, sir.
There also
That I
it's the
remember.
same. There also it's the same method. Okay. All 6 trigonometric functions and their derivatives you should know, as well as 6 hyperbolic and their derivatives.
Okay, sir.
Okay, just do sin h inverse one. Then ma?
No, sir, not yet.
No, sir, not it was.
Sir, I'm getting the same thing for sine h inverse x.
You should get 1 plus u square, 1 plus x square.
Yes, sir. I'm getting x square minus 1. I
No,
don't
no,
know
you should
why.
get 1 plus x square because it's instead of sin hy, you'll get cos hy, right?
Yes, sir.
Cos hy is 1 plus sin h square y. Okay. Sin hy is actually x.
Okay,
Understood?
sir.
Got it, no? Just check
Yes,
again.
sir.
You should get this one only. 1 by under root 1 plus x square.
Sir, is different sin HY when we differentiate, is it supposed to be minus cos HY?
Sin hy, if we know this, no? Sin hy should be cos hy only.
Okay,
See,
sir.
sin h inverse x equals to y, right? That means sin
Yes, sir.
hy equals to x, right? That means cos hy dy by dx equals to 1, right? That means dy by dx should be equals to 1 by cos
1
hy,
by cos HY.
which is nothing but 1 by 1 plus sin h square y, right? Which is nothing but 1 by 1 plus x square. Sorry, this is square root of this. Understood?
Sir, is sin square HY minus cos square HY equal to 1 or cos
No,
square
no,
HY
cos
minus
square minus sin
sin
square
square?
equals to 1. Cos square minus
Oh,
sin
sir,
square
I did the
equals
other way.
this one. See, cos square minus
That's
sin
why I
square
got it
equals
wrong.
to 1. Okay, ma?
I did the other way.
Okay. Now you got it, no? Remaining ones also you can
Yes,
do
sir,
like
now I
this.
get it.
Okay. So now, okay. So this ones you know. Now this kind of integral, what you will do?
My lord.
You know 1 plus x square is actually 1 plus x square integral of 1 dx by 1 plus x square equals to square root of 1 plus x square equals to sin h inverse x, right? This is plain antiderivative. Now here a square plus u square is there, right? What do you write? You will write it as a square times 1 plus u by a whole square. Okay? Du. Right now. Now u by a you can
Yes,
take it
sir.
as t, the substitution. Okay, u by a you will take it as t, you will get this one. Just try this. Understood? Try doing a small substitution and get this answer. You know dx by under root 1 plus x square equals to sin h inverse x.
So the x we're supposed to convert to u by a, then root.
Right. So u by a, you will take it as some t. Then du equals how much? 1 by a dt, right?
Yes, sir.
Like that. Sorry, this is a square will not come out. It's I think a only will come out. U by a equals to t, du equals to a dt, right? So that a and this a will cancel. We'll get dt by 1 under root 1 plus t square, which is nothing but sin h inverse t, which is nothing but sin h inverse u by a. Understood?
Yes, sir.
Got it, no? Shreyas, you also got it, no? Ma?
Yes, sir.
Okay, so a square plus x square, a square minus x square. This is slightly modified version of 1 minus x square, 1 plus x square, like that. Okay? Just that x by u or x by a, you will take it as substitute. Substitute that one you will take as some t or p or whatever. Okay, ma? Okay. So now
Sir, why
these are
does a come out common?
what? Just for
Sir,
this,
how does
we are taking a common. No, this we'll write it as a square times 1 plus u square by a square. We can write it like this, right? And this one we can write it like this, no? A square plus again u square. So this we can take a common and u by a whole square, right?
yeah?
Understood, no?
Yes, sir.
Okay. So now you know. Okay. So please note all of this. Okay. Derivatives of all hyperbolics you know, and their corresponding antiderivatives. Okay. Now derivatives of
Okay.
all inverse hyperbolic you know, right? All and their corresponding antiderivatives, right? Right. Sin h inverse
Yes,
x
sir.
and this or either 1 plus u square or a square plus u square, all are more or less same. Okay, and then you got this. Okay, similarly derivatives of inverse trigonometric functions, Okay. This is the list of all inverse trigonometric and inverse hyperbolic derivatives. Okay. Of all of this, the most important ones are this sin h inverse, tan inverse, sin h inverse, cos h inverse, and tan h inverse. Okay. You remember all of this, no?
Yes, sir.
Just remember these 1, 2, and 3 and 4 on priority. Okay. Sin inverse, sin h inverse, tan h inverse. Okay. And
Okay.
this one also, cos h inverse. Okay. You remember all of this, no?
Yes, sir.
Okay.
Sir, for tan x, tan inverse, tan h inverse, what do we do? We just use.
Same thing. Tan h x equals to y. I mean tan h y equals to x. Then tan square
Yes,
and
sir.
tan
In
h square
between, we
and
have
sec
to use a
tan h
formula,
square
yeah?
and secant square are related again. See, these are related, no?
Yes, sir.
Okay. So okay. Try these also. Okay. Fine. Try doing tan h inverse x. Okay. Try doing tan h inverse x once and see whether you are getting this thing or not. Tan h inverse x, you have to differentiate. Tan h inverse x equals to y. Okay.
Sir, once again, can you tell the relation between sec square and then tan square?
Yes. Okay. Okay. Write all of this once in a notebook. Write all the six, 7 relations.
Yes, sir. Once.
Okay. Anyway, I'll send this PPT also. Okay. But write all of the 6 relations. 6, 7 relations. Okay.
Yes, sir. Once again. Done, sir. Sir, done, sir.
Got the derivative of tan h inverse, ma?
Yes.
Okay. Very good. So, okay. So now you know all the integrals of these ones, right? Okay. Now watch carefully. This one, you know. What is the. This is part of your syllabus. Okay. Now tell me what exactly is this? What exactly is this integral? X square plus a square. That is.
Sir,
Where is
it's
this? That is tan. Okay, that is this, right?
Yeah.
Tan inverse x, right?
Yes, sir.
Tan inverse x, okay. Just do the small substitution and tell me x square plus a square. What will it become? What is the substitution? We'll take a square common, a square into x squared by a square, right?
Yeah.
Agreed? So you'll do the substitution and you will
Yes,
be
sir.
able to do this, right? So for example, like this, x squared by a square is a square into 1 plus x by a whole square, and then x by a you will take it as t, right? Dx is a dt, right? Dx is a dt by a square into 1 plus t square. This becomes 1 by a dt by 1 plus t square, 1 by a tan inverse t, which is nothing but tan inverse x by a, right? This is our first
Yeah.
integral, right now? Okay. And what is this one? This one is straightforward. What is this? Tell me. We just did sine inverse x by a, right?
Yeah.
That is what sine inverse x by a. Where did we do? This is pretty straightforward. This is sine inverse x by a, right? We'll take a common.
Yeah.
X by a is t, so sine inverse x by a. Okay? These two are pretty easy,
Okay, sir.
right? Right. Now tell me x square plus a square. X square plus a square we did. Where is this? X square plus a square. This one, right?
Yes, sir.
This is x square plus a square. X square plus a square. Okay. Try doing that substitution and tell me what is x square plus a square. X square plus x square. Uh, a square into 1 plus x square. Sorry, this one is done, no? Which one? Square root of x square plus a square. Just use that sine h inverse x, differentiation of sine h inverse x, and do this and tell me x square plus a square.
Yes, sir.
Okay. So basically, we have, see this, a square plus x square. I mean, we have all these combinations. What are those combinations? 1 by x square plus a square, right? And then 1 by a square minus x square, or a square plus x square, right? A square minus x square, a square plus x square, which is the same, right?
Hmm.
Understood. So what are the combinations? 1 by x square plus a square, a square minus x square, or 1 by x square minus a square, right? Okay. So now if it is 1 by x square minus a square, you can still write it as minus 1 by a square minus x square, right? That's why he is not given x square minus a square. Okay, he has given only this. This will actually solve this as well as the other one, right? And a square
Yeah.
plus x square, it will again solve for both one. And minus a square minus x square, you will still write it as minus 1 by a square plus x square. So that will also satisfy here. So all combinations are satisfied here. Agreed? All combinations of plus or minus a square and x square is sorted here in this and this. Agreed?
Yes, sir.
Okay, this one we have sorted, and this one you are doing using sine h inverse. Half of it, x square plus a square, you are doing it. What is this? X square plus a square? Okay, x square plus a square, we know sine h inverse x by a. How did we do? We took a common, okay, x by a, and x by a equals to t, and then we are able to do this. Agreed? This
Yeah.
is sine h inverse x by a. Agreed, ma?
Yes, sir.
Okay, and we know sine h inverse x. We discussed that formula, right? Sine h inverse x, you can express it in terms of logarithms, which is this logarithm. Okay, clear?
Yes, sir.
Okay, next, what about under root of x square minus a square? Okay, okay, did we discuss this? X square minus a square? Okay, x square minus a square, we can write it like this, right? X square minus a square, we can write it as 1 by x minus a into x plus a, right? Right, ma?
Yeah, yeah.
If we write it as 1, we can still write it as 1 by x minus a minus 1 by x plus a. Denominator will become x square minus a square, but numerator will become x plus a minus x minus a, which is what we'll get 2a. So we'll divide everything by 2a. Understood? So this we can write it as 1 by 2 into 1 by x minus a minus 1 by x plus a, right? Okay.
Yes, sir.
Okay. So this we can easily integrate now. This is log of x minus a. This is log of x plus a. Okay. So 1 by 2 into log of x plus a, x minus a minus log of x plus a, which is log a by b, which is log x minus a by x plus a. Right? Understood?
Hmm.
Okay. If it was the opposite, a square minus x square, it will just become the opposite. We'll write it as minus 1 by x square minus a square, and we'll still get the same thing. Just that this log will get reversed. Okay. X plus a by x minus a. Okay.
Okay, sir.
Understood now? So this one we are able to do. This one we are able to do. This one we are able to do. Agreed?
Yes, sir.
Okay. So these parts are clear. Now let's go to the next one. This one, root of a square plus x square, we are able to do. Right? Sin h inverse. Okay. Now root of a square minus x square. Okay. Root of a square minus x square, we can convert this into 1 minus x by a whole square, which is nothing but sin inverse, regular sin inverse x by a, right?
Yes.
Okay. And root of x square minus a square, we can use cos h inverse, right? Where is our cos h inverse? This one. Okay.
Yes, sir.
Understood. So what we are saying, this is tan inverse, right? This is a square plus x square is sin h inverse, and x square minus a square is what? Cos h inverse, right? X square minus a square. X square plus a square is sin h inverse. X square minus a square is cos h inverse, right? This gets to cos h inverse. Understood? And a minus x into a plus x. This will break into two parts and we'll get log a by b format, right? Understood?
Yes, sir.
Clear, ma? This one,
Yes.
this one is plain sine inverse. Okay? Are you clear about all combinations?
Yes, sir.
Okay. So we have got 1 by x square plus a square. What do we do here? This is plain tan inverse, right? 1 by
Hmm.
x square minus a square. What we will do here?
Sir, mine.
We'll write it as 1 by x plus a, 1 by 2a into 1 by x minus a minus 1 by x plus a, right? And we will write it as log of a by b, right? This we integrate log a minus log b, right, Noma?
Yeah.
Agreed. 1 by the opposite of this is 1 by a square minus x square. This we'll rewrite it as minus 1 by x square minus a square, and we are done, right? And if you get
Yes,
both
sir.
negative, 1 by minus a square minus x square, okay? We'll still write it as minus 1 by a square plus x square, which is nothing but, again, tan inverse. Right now? So, x
So it
square
will be minus tan inverse here because
minus
it's
tan inverse,
minus.
right? Minus tan inverse, right? It's the same method, right? We are not doing anything. So, both x square, both positive, one positive and negative, and both negative, all are done, right? Agree now?
Yes.
Okay. Next, what
Yes,
is
sir.
the next one? The next one is again same, under root of a square minus x square. Okay, under root of x square minus a square, right? Under root of a square plus x square. Okay, and what is the fourth one? Under root of minus a square minus x square, right?
Yeah.
A square minus x square. This is what? Sine inverse, right? This is what? This is cos h inverse, right?
Law. Yeah.
Cos h inverse. This is what? Sine h inverse, right? What about this? This is not given. See, in this syllabus also, this is not given, right? Root of minus x square minus a square. Why is it not given? Because this becomes a square is always positive, x square is always positive, and root of negative number it will become, right? So that's why this is not
Yeah.
there. Understood now?
Yeah.
Understood now? So we have root of, you can see, root of x square plus a square, x square minus a square, or a square minus x square. We don't have the fourth one. We don't have minus a square minus x square, right? We have x square plus a
Yeah.
square, x square minus a square, or a square minus x square. We will not have that fourth one. Okay? So
Yes,
now
sir.
you know this 1, 2, and 3, 4, 5. These 5 you know clearly. Right? This is tan inverse. This is combination of cos h inverse and sin h inverse. This is actually a logarithm minus logarithm. This is actually sin inverse. Understood?
Yes, sir.
Okay. Now whenever there is a quadratic function, okay, ax squared plus bx plus c is a quadratic function, right? Agree, ma?
Yes, sir.
Ax squared plus bx plus c is always a quadratic function. Okay, so quadratic function means you can always, the completing the square method.
Yes, sir. Yes, sir.
Okay, so ax squared plus bx plus c, you can always write it as some square plus some constant, right?
Yeah.
Some square plus or minus some constant, right? This right? Because completing the
Yeah, we
square
know
method,
that, sir.
right? So when you are able to write this as some square, some plus constant, that means you are able to uh, rewrite this in the format of either this or this, right? So I'll give you some example.
Yeah.
Okay, let me show you some example. Okay, see, this is a quadratic equation. Okay, this is a quadratic equation. That means you can write as difference of this and this, right? X minus 1 whole square minus root of 7 by 2 whole square. Now you can take some proper substitution. This is in the form of x square minus a square, right? Or you can take a substitution, x minus 1 equals to t. Then this becomes t square minus whatever, a square, right? Again, we are able to convert this into one of those forms, right? What is this form? 1 by x square minus a square, which is again your logarithm form, right? Okay,
Yeah.
whenever you are given dx by ax square plus bx plus c. Okay, see, this we are
So
able
this
to
one will
convert.
be 1 by 2 a log x minus a by x plus a. Yeah?
Yes, yes, that's it. That's what we have done here. See, log of this minus this by this plus this. Okay, understood.
Yes, sir.
Whenever you are given this form, we will convert this into some square minus some square or some square plus some square, etc. Something like that, right? You can always convert. Either it is some constant square minus some x plus a whole square, or x plus a or x minus a whole square minus some constant square, right? So this one, say
Yeah.
for example, this one we are able to express in this format. Now we'll take x plus half as some t, and then this becomes t square plus this one. This is plain tan inverse t by this thing, tan inverse t by a, this one, 1 by a tan inverse t by a, right? Understood now?
Yeah.
Okay. So this one is pretty straightforward. This one converts to either this, right, or this, right now?
Yeah.
Okay.
Yes.
Similarly, by the same logic, there's a square root here. This one converts to either this or
Or the
one
other
of
one.
this, or the one of this, right? So
Yeah.
the fundamental thing is 1, 2, 3, 4, 5, 5. If these 5, if you know, that means these two are automatically known. Agree?
Yeah. Yes,
Agree.
sir.
Now, earlier I think you did one of these using by parts. Which one? A square plus x square or x square one of these using by parts. Just now you did, right? Do you remember
So
doing
the
by
one which
parts?
we take x common out, yeah? X square.
Yes, yes. So one of them you take. Okay, let's discuss about these also. Okay. So how many are left? This, and this are left. Okay.
Hmm.
Okay. So now first we'll understand how to do these two. Okay. Firstly, these four are the fundamental ones, right? What are these? Sine inverse, tan inverse, sine h
Yes.
inverse, cos h inverse, right? These
Yeah.
four are the fundamental ones. After this, we depend on these for lot of other things. Okay. Now let's do for these two. Okay, ma? Understood, no?
Yeah.
Okay. Okay.
Yes, sir.
Let's do this one. under root x square minus a square. Okay, we have two methods. First one is by parts we will use. Okay, substitution we'll discuss it again. For now, by parts. First function is this, second function is 1. Okay, so what do we do? First function is under root x square minus a square. Second function is 1. Derivative of this is 1 by 2 under root x square minus a square into 2x, right? Integral of this is this. So this into this, right? Minus integral of 2x square. This 2 and this 2 will get cancelled. X square by under root x square minus a square, right? Dx, which is x under root x square minus a square. This one. Okay. This part is there now. Now what we'll do?
Yeah.
We want to split in such a way that we'll get again our original line. What we will do? We will do minus a square plus a square. Okay. So this integral will split as minus I minus integral of a square by under root x square minus a square. Right? Agreed?
Yes, sir.
Agree or not?
Agreed, sir.
This one is minus I, right? X into under root x square minus a square minus I minus a square into this one. But this we already know. What is this? This is one of our first four fundamental ones, right? X square minus a square. This is what? This is our cos h inverse, right? So here also we have used our first four fundamental ones, right? Now understood the importance of first four. Understood, no? So here we are using again this one, right? For this, we are actually using this. Understood, no? Understood, Nama? Okay, so then A equals this minus A minus this thing. So 2A will become this minus this, and A becomes, this minus this by 2. Understood? This is what we have got. Clear now?
Yes, sir.
X square minus A square. So now we have A square plus X square and A square minus X square. A square plus X square, again the same thing we will do. First function, this is by parts, right? Till this part it is very clean, right?
Yeah.
X by under root A square plus X square, right? Okay, so again we are doing the same thing. X square we are doing plus A square minus A square, right? Okay. Agreed, ma? This part is clear?
Agreed, sir.
Okay, this one what we are
Yes,
doing?
sir.
Tell me.
No, no, sir. Yes.
Okay. So what again we are doing? We are doing by parts so that we want to express A again in terms of A. So A equals this minus A plus something. Right? That means 2A equals to this plus this and A equals to this by this. Okay. So effectively what we are doing in these two cases we are actually this case also. We are using what we are using? We are using this one, right? In some form, right? We are using actually this in some form. In this case also we are using this in some form and A square plus X square this in another form, right? In both the cases you will get this. Understood? Understood. So what I suggest, okay, try doing one of this. Okay, try do this and get this answer. Using by parts you do this.
Sir, yes, sir, I got the final answer.
You got the answer?
Sir,
Yes.
not yet done, sir.
Okay, okay. Easy now?
Yes, sir, it's easy itself. It's not that hard.
Integration is easy only. Just that you should know the trick. Okay. There is only one substitution method and another partial fractions. Both are easy.
Partial.
Okay. Partial fractions method. So, okay. So, look at your syllabus. Now, just see, all are familiar. Fundamental integrals using trigonometric exponential logarithmic
Sir,
functions.
can you show the answer once?
1 second. This one only did, no?
Yes, sir.
Got it, Nama, this one?
Yes, sir.
Okay. So, integration by substitution, you know, right? Exponential logarithm, you know. By parts, you know. By partial fractions, I will tell you. Okay. Trigonometric identities, you know. And all of this, you know now. Right? One,
Yeah.
this, and this, you know. Okay. Then we'll learn about these two also. These two are nothing. This one again you will convert first to this, and again again to one of these. This one also you will convert to again to this, and again one of this. That's it. So fundamentally all of these are dependent on these four only. Okay, everything
Okay,
else you
sir.
will convert to one of these four. You do some manipulation and convert to one of these four and do it. Okay, ma?
Sure, sir.
Nothing much complex here. Everything whichever you are given, you will convert to these four only using some algebraic manipulation. Okay, cool.
Okay, sir.
So remaining we will see next class. Monday, what time, ma? Monday only, no? What time?
Sir, Monday.
Sir, Monday 7:30, right?
7:30 only?
Yeah.
Yeah.
Okay, cool. 7:30 IST.
Yeah. Okay,
Okay,
sir.
take
Thank you,
care.
sir.
Bye
Bye,
bye.
sir. Bye.
Thank you, sir. Bye, sir.
Bye, ma.